Hello guys. So in this video we are going to discuss the solution of the problem sort an array of zeros, ones and 2. So let us take a look on the problem statement. So the problem statement says that we are given an array of size n containing only zeros, ones and 2. Sort the array in ascending order. So basically we are given an array which contains only zeros, ones and 2, and we need to sort the array in ascending order. Okay, so now let us see how we are going to solve this problem. So in order to solve this problem, there are multiple solutions exist. One solution which is an optimal solution, but let us discuss it, which is a very natural solution, is basically, so let us say we are given an array, and let's take the example 0, 2, 1, 2 and 0. So what we are going to do is we will have 3 pointers. So number of zeros. Okay, so let us say one pointer which tells us the how many numbers of zeros are present in the array. The second pointer tells us the numbers of 1, and similarly the third pointer tells us the number of 2's. Okay, so for instance in this particular case the number of 0 is 2. This is right, and once we have this information with us, what we will do is that we will iterate on the array one more time, and uh, the first two elements we will set it to 0. Then we know there is just one, so that is what we will do, and the remaining is 2 2's, right? So that is how one way of sorting it. And the running time complexity, if we analyze, is order of n, and we don't need any space here, right? But the thing is that we have to iterate this array twice, right? This array twice. One we are iterating to formulate this, right? This data, to populate this data, and the second time we are iterating in order to manipulate the array in order to get our manipulating the array to sort the array basically, right? So we have to iterate it twice. Now there are algorithms available, or we can do it efficiently in just one iteration itself. Now let us take a look on the solution where we have to just iterate it once and we will be able to sort the array. So this thing basically depends upon this way. So basically let me take the example. So 0, 2, 1, 2 and 0 is given to us. So what we are going to do is that we will have 2 pointers. So this will be my start pointer, and there will be an end pointer, and we will set the end pointer here, and then there will be an index, which is what we are iterating on. Okay, the idea behind this is basically there are 3 conditions which will arise here. So let us write down the condition 1. So the condition 1 is basically if ARR index is equals to 0. So that is one condition, right? The second condition is if ARR index is 2, right? And the third condition is if ARR index is 1, right? So these are the 3 conditions which could occur in this array, since the array contains only zeros, ones and 2. So these are the only 3 conditions which could occur, and let us see how we are going to manipulate it. So the way we are going to manipulate this is basically start contains the element. So this start denotes that all the array or the sub array before to start contains only zeros. Okay, similarly all the element after end contains 2. Okay, so let us say if this is an array, okay, let's take just a random array and there are various elements to this array, and let us say our start is at this position and our end is at this position. Okay, so we know that all the elements before to start is 0 and we know that all the elements after end is 2. Okay, and if at all I encounter any element which is either 0 or 1, 0 or 2, and let us say our index is somewhere here. Okay, and if at all here is our index. Now what will happen is that if index is 0, then what we are going to do is that we are going to swap start with index. If index is 2, then we are going to swap it with end. Okay, and if it is 1, we are not going to do anything. All right, so I'll repeat it one more time. So if ARR index is 0, so if ARR index is 0, then swap ARR index and ARR start. Okay, so since we have swapped ARR index to ARR start and ARR index is 0, so now this, let us say index we have swapped it to index we have swapped it to start, so now this element will contain 0. Now since this element contains 0, so we are going to increase s to 1 pointer. So once we will swap it, and then what we are going to do is that we are going to increase our start counter by 1. Okay, similarly, if as ARR index is 2, then we are going to swap ARR index with ARR end. Okay, after swapping, ARR end will contain 2, so what we are going to do is that we are going to decrease end index by 1. Okay, right, and if index equals to 1, then we are not going to do anything, we are just going to increase our index counter. Okay, so this is the core logic of the solution. So there is just one remote case or a corner case. To address that corner case, we are going to add one more condition over here, which is basically, now it might be possible that my start and index are at the same location, right? It might be possible that both are at the same location. In such cases, what we are going to do is, if my start is equals to index, then apart from increasing my start counter, I will also increase my index counter. Okay, similarly here it might be possible that my end and start position are same, sorry, my end and index are same, right? In which case I am going to increase my end also. Apart from decrementing my end pointer, I am going to increase my index pointer. Okay, so that's about the explanation part, folks. Now let us jump to the coding section to see the code of it. So I've already coded this. Now let us take a look on the solution. So the solution goes something like this. So my start position I have initialized is to 0, my end to n minus 1, and my index starts with 0. Now the three conditions we talked about: if index equals to 0, if index equals to 2, and if both the cases are not there, then index will be equals to 1, right? So if index equals to 1, then we are just going ahead and increasing our counter. We are not doing any manipulation. If index equals to 0, then we are swapping index and start. Once we have swapped the values, I have increased the start by 1. Okay, and the corner case which we talked about, if start and index are equal, then we will increase the index counter also. Similarly, if it is 2, then we are going to swap it, index and end, and we are going to decrement end. Similarly, if index equals to n, then we are also going to increase our index counter. Okay, that's about the coding aspect. Now let us submit our solution. So our solution got accepted. So that's about the video, folks. If you have any questions, queries regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.